right, so we're going to find the area of regular polygons. When we talk about regular polygons, remember that means all sides are congruent. All angles are congruent, all sides are congruent. If I were to inscribe a regular polygon, this happens to be a pentagon, but if I were to inscribe it in a circle, that means all the vertices are on the circle, right? So if I were to draw a segment that goes from the center to a vertex, that's a radius. It's a radius of the circle, and actually is a radius of the polygon. We usually don't talk about a radius of a polygon, but it is there. And it's typically only with regular polygons. If I were instead to draw a segment from the center of that polygon and circle to the edge of the polygon, and if it makes a right angle, that segment is called an apothem. Okay, it's called an apothem. We're going to be working with our apothem today. All right, so I have for you here a pentagon. Okay, and I've divided this pentagon into 5 isosceles triangles. All right, divided into 5 isosceles triangles. First thing I want to do is I want to come up with the area of this one single triangle in terms of A and S, meaning I'm going to leave A and S in my answer. I'm not going to plug in any numbers. We're not going to get like 12 for our answer. Okay, so how do I find the area of a triangle? 1/2 base times height. So area is equal to 1/2. What is the base of this triangle? S. And what is the height? A. All right, so that would give me the area of this single triangle, right? But I want you to think about, we have more than one triangle in this pentagon. How many triangles like that do we have? How many concurrent triangles do we have? We have 5. Okay, so if I wanted to find the area of a regular pentagon, I'd have to take 5 times 1/2 SA, right? Well, what's going to happen if I have a hexagon? How many triangles am I going to have then? 6. 6 times 1/2 times S times A. But what if I had a heptagon? Maybe 7. If I had an octagon, I'd have. Okay, so this would keep going forever, right? But we're looking to find a formula. So if I had n sides, it would be n times 1/2 times S times A. Right? N standing for the number of sides? Yes.
Would that be the simplified n over 2SA?
You could, but you don't. A lot of times, I'll show you how they write the formula. So a lot of times we write the formula as area equals 1/2 NAS. 1/2 NAS. I don't know why they picked that order, but they do. All right, so 1/2 NAS is our formula. That'll get us the area of any regular polygon. So it's listed out here. A is the area, capital A is the area, sorry. Lowercase a is the apothem, S is the side length, and N is the number of sides, which we kind of figured out, right? All right, so now, keep in mind, if I were to put N and S together, so N is the number of sides, S is the side length, what would that tell me? N times S would actually give me the perimeter of the figure. So sometimes they write the area as area equals 1/2 AP. So they really just took the N times S and said that's equal to perimeter. Sometimes one formula is a little more handy than the other. And we're going to see that here in a couple of examples. Any questions about the formula or what all the variables mean? Okay, so let's start with this octagon here. We want to find the area of the regular octagon. So I know area equals 1/2 NAS. So N is number of sides. How many sides do I have?
8.
We have 8 sides. That's my apothem length. 15, and my side length is 20. So go ahead and multiply that all together. What do we get? Good. So 1,200 square centimeters, right? Now, at this point, as far as the information you know, the geometry that you know, I have to give you the apothem and the side length almost for everything. There's only one exception. We're going to talk about that exception now. Okay, so we're going to talk about that exception now. The exception is if you have a regular hexagon. So I want to talk about why this exception is. So if I have a regular hexagon, and I were to draw in all those individual triangles. Okay, create 6 triangles, which isn't a surprise to us, but we need to think about the measurements of those triangles. If I were to take my 360 all the way around to the inside here, divided by 6, what do I get for each angle measure? 60 degrees. Okay, now, remember how we talked about these are all equilateral, they're all isosceles triangles because these are radii, right? Radii in a circle, so these are isosceles. That means my base angles have to be congruent. So it ends up being not only isosceles, it ends up being equilateral. Because it's equilateral, when I draw in that apothem, when I draw in this apothem, what's happening is I've created now a 30, 60, 90 triangle. Okay, so when I draw in this apothem right here, this angle is 60, this is being bisected, so that's 30. We have that 30, 60, 90 triangle. So if I know a side length, right, I know the side length is 14 in this case. I try to move that. Okay, so the side length is 14. So keep in mind, if this is isosceles, remember it's bisecting the base, which means then the little leg, the small side has to be 7. Is that okay? Just my short leg is 7. So now I can find my apothem, which is the long leg. So I get 7 radical 3 for my apothem. So I'm just using that special right triangle there. Okay, so now I can do my formula. Area equals 1/2 NAS. So I have 1/2. How many sides do I have? 6. My apothem length. 7 radical 3. And what's my side length? 14. All right, so we can go ahead and multiply that together. I have 294 radical 3. Okay, so the hexagon is the exception. I don't have to give you all the parts. I can just give you one piece, and you can, if I give you the apothem, you can find the side length. If I give you the side length, you can find the apothem. Okay, every other shape, though, I have to give it those parts to you at this point. I'll change in a couple weeks. All right, last problem. Last problem here says find the perimeter of a regular nonagon with an apothem of 9.6 centimeters and an area of 302.4 centimeters. All right, so because I want to find perimeter, remember we had the formula that took n times s to get the perimeter? So I can use the formula 1/2 AP. You can also do this by not using this formula. The only difference is when I solve, when I end up solving, I'm actually going to be leaving 2 things on the right. We're used to solving, for 1 variable. We have to solve for 2, the n times s. Okay, which feels a little goofy and awkward. All right, so let's plug in what we know. We know the area is 302.4 equals 1/2 times my apothem is given to us. That's 9.6 times my perimeter. So I can simplify the right side, take 1/2 times 9.6. I get 4.8. So I have 302.4 equals 4.8 times the perimeter. I can divide both sides by my 4.8 there. And I get 63 is my perimeter. What if I asked you now a follow-up question, what's the length of each side? I heard somebody say it. It's 7, right? Because we were told we have a nonagon, that means it has to have 9 sides, so n times s, right? N times s is my perimeter. The number of sides is 9, so that gives me 7 for my side length. I didn't ask you that, but just to add on to it. Questions on that? Okay, so the worksheet that you have, the front is pretty straightforward. I'm giving you, for most of the part, most time I'm giving you the opposite and the side length. There's a couple hexagons at the bottom. There's 2 more hexagon, or no, there's equilateral triangles at the top on the back. And then just some composite figures, meaning figures that you can break into those shapes we recognize, the triangle, parallelogram, circles, okay? All right, so I'll give you the rest of the time to get started. Don't forget you have the surface area stuff for tomorrow as well. And I'll post all that to Google Classroom